An idea born in unsettled times.
We are going forward. America, the United States, is first in space.
Becomes a feat of engineering excellence. The most complex machine ever built to bring humans to and from space.
Bye, roll, Discovery.
And eventually construct the next stop on the road to space exploration.
We are on a true spaceship now.
As 30 years of flight draw to a close, its legacy is one of unsurpassed achievement. Tragedy overcome and opportunity met. NASA's Space Shuttle. At NASA's Mission Assembly Facility in New Orleans, production begins on the shuttle's external fuel tank. The last of 136, produced here since 1973. Unlike the orange external tank that is used only once, the boosters detach themselves and parachute into the Atlantic Ocean. They are then retrieved, refurbished, and reused on later missions. The shuttle mission's crew is assigned.
Folks on there that are like my brothers and sisters. I mean, we really do get close after a year of training for a flight and having flown in space together. And there's a special bond that comes with that.
Right up until launch, a shuttle crew will train in a variety of critical regimens, some basic, others specific to their mission. And underwater in the world's largest indoor pool. STS-134 astronauts floating in actual spacesuits, trained to work during extravehicular activities, or EVAs. The Neutral Buoyancy Lab, or NBL, at NASA's Johnson Space Center in Houston, is the best simulation of microgravity on Earth, and ideal for practicing spacewalk. The rollout. Looking now much like it will at liftoff, the space shuttle is carried to the launch pad atop the 6 million pound crawler transporter at a blazing pace of less than a mile an hour. Not exactly warp speed. The economy is sliding into recession, and with a race to the moon already won, the Apollo program is canceled. A new mission is sought for NASA to send humans into space, but Mars, for many the next logical step on the path of exploration, is dismissed as too costly, a destination for a country preoccupied with events back on Earth. Instead, on January 5th, 1972, another destination is selected, low Earth orbit. As early as the mid-1960s, NASA had concluded that the technology was available to build and fly a reusable spacecraft.
President Nixon really liked the idea and told the NASA administrator, go do it. And the NASA administrator got a call from OMB the next morning, someone there, and said, hey, what the president really meant to say was, you're going to get this much money, and so do as best you can with the space transportation system. And our choice, logically, was you have to have a vehicle first, and so that was the birth of the space shuttle as the first in the three-part space transportation system.
Engineers also considered how this new orbiter would be propelled safely out of the reach of Earth's gravity. At the Marshall Space Flight Center in Huntsville, home of the rockets that had sent every Mercury, Gemini, and Apollo astronaut into space.
All engine running. Liftoff. We have a liftoff.
Design teams would devise the partially reusable propulsion system that would finally be adopted.
Originally, it was going to be an air-breathing airplane that would fly to space as a rocket and then come back to Earth. The orbital maneuvering system pods that sit on the back now were to be where deployable air-breathing engines would come out, and it would be able to fly from its intended point of landing to another place if the weather were bad or something like that.
NASA's new shuttle would essentially glide its way back to Earth. September 1976, more than 4.5 years after President Nixon signed off on its development, America's new spacecraft, Constitution, gets its first close-up before the cameras. The orbiter itself was well received by the public, but impassioned fans of a particular long-canceled television series called Star Trek wanted it called something else. They staged a successful write-in campaign, and the orbiter was renamed for the Starship featured on the show. Thus, NASA's new shuttle would be the Enterprise, boldly going as no spacecraft had ever gone before.
A very aggressive flight test profile that consisted of data points continuously all the way down. There was not a matter of 10 seconds went by without another either pitch doublet or a rudder kick or an angle of attack sweep. The things that really turn on a test pilot to fly them as accurately as possible.
August 12, 1977. On a crystal clear California morning, high above the Mojave Desert, 2 NASA test pilots ready for Enterprise's first flight. The plan was for Fred Hayes, Jr. and Gordon Fullerton to lift the orbiter off a modified 747, then land on a dry lake bed 15,000 feet below.
There were still questions about was it going to actually happen as we expected from those simulations and the analysis and everything. There's a very loud thump when the shuttle separates. There was always a question, was the shuttle going to slide back and hit the tail of the 747? But we couldn't see that, but we could, after a few seconds, we could tell it didn't hit us. And so the chase called clear.
Columbia, NASA's first orbiter, is fittingly named after the first American vessel to circumnavigate the globe. However, Columbia quickly becomes a daunting challenge for NASA. Its complex makeup had engineers struggling constantly to reduce Columbia's weight and simplify construction. Especially frustrating was keeping the orbiter's ceramic tiles attached to its fuselage.
So you can't have a metallic system on it that weighs tons. It has to be extremely lightweight. And in fact, the shuttle tiles are about 90% air, and that gives a combination of being able to be temperature resistant and yet at the same time light.
Each orbiter has a unique number of protective tiles. Challenger was built with the most, 31,088, while Atlantis has the fewest, a mere 24,177. And the problem overcome. Other shuttle design features proved less problematic and more groundbreaking. A computerized digital flight control system, now common in commercial and military aircraft, was developed for the orbiter.
In flying the space shuttle, you were so aware that you weren't necessarily talking to the shuttle, you were talking to a computer who in turn was going to talk to the shuttle.
Barriers of race and gender were falling everywhere, and America's core of shuttle astronauts would become more reflective of the nation it served.
There's been a lot that the shuttle era has done to bring spaceflight into the domain of the average person. We know it's not just crew-cut white test pilots anymore. It's essentially the United Nations that flies on the space shuttles. It's people of every description that look very much like the rest of us.
The astronaut selection process reflected a changing nation and a changing NASA. STS-26 ended on October 3, 1988, at Edwards Air Force Base, California, with Discovery's safe landing on runway 17. The triumphant crew was greeted warmly by Vice President George Bush on behalf of a proud and grateful nation.
There's something special about a return to flight that makes you have some trepidation because it's still fresh in your mind that you're frail and you can make mistakes and you're human.
In the spring of 1990, the $1.5 billion Hubble Space Telescope was loaded into Space Shuttle Discovery's payload bay, and on April 24th was sent aloft to be deployed to Earth orbit on STS-31.
Capcom, we have a go for release. Discovery, go for Hubble release. Okay, we have a go for release.
As envisioned, Hubble would return never-before-seen images detailing our universe as it was millions upon millions of years before. Soon it would become clear that Hubble pictures were not.
Several days later, if not a couple of weeks, we found out after we were back on Earth that it had a problem with its vision. And most of us were just devastated, that here we had this marvelous instrument that we had put on orbit and it was going to be useless. It turned out that it wasn't useless at all because even with its flaw, it was still a much better telescope than anything that we had, on Earth.
A shuttle mission dedicated to the telescope's repair was planned. In essence, Hubble's nearsightedness would be corrected with a new pair of glasses.
Liftoff of the Space Shuttle Endeavour on an ambitious mission to surface the Hubble Space Telescope.
We finally flew STS-61, which was the first Hubble servicing mission. Absolutely incredible mission.
Clearly we have a dynamic situation.
You cannot take the 84-inch mirror out of the telescope. It's part of structure, too big, it's there. So by putting in one box called CoStar, we're able to correct aberrating light for 5 other instruments.
Of all the space shuttle missions we've flown, it was without a doubt the most ambitious flight, but the one that I think demonstrated NASA's can-do attitude, its technological skill, its technical capability, and the spirit of its people.
2 teams of astronauts made a record 5 back-to-back spacewalks to refurbish Hubble and realize her potential to awe and astound. While Hubble surfacing missions were very important, the true gift of a maneuverable shuttle was soon realized in a very different rescue mission.
Booster ignition and liftoff of the maiden voyage of Endeavour on a satellite rescue mission.
Months earlier, in May of 1992, the 7 astronauts of STS-49 overcame initial setbacks to pluck the $180 million Intelsat-6 communication satellite from an unusable orbit.
It was going to be a very simple rendezvous, get close, bring the satellite down close and grapple it with the remote manipulator system. Everything that could go wrong went wrong.
We got up there to capture it. The bar, we tapped the satellite with the bar, and the satellite started moving out of control.
Get in, hit me over. Into the arm, watch the arm.
We have to take it out again.
You're going to have to get out of there.
It can be very difficult catching something like a tumbling satellite in space. The slightest touch or mistouch by the astronaut with the equipment, and you can send that satellite tumbling.
Yeah, make sure that when you want me to yaw right, you say yaw right. Okay, the other time right, it's just right. Yeah, that's what I'm doing. Okay, we're moving.
And so it was very touch and go on that mission, actually.
Commander Dan Brandenstein and pilot Kevin Chilton are preparing for the upcoming terminal initiate burn.
After several days of failed attempts with Endeavour's remote arm, Commander Dan Brandenstein literally tries a new approach.
Yeah, real easy, guys, real easy. Don't bring us any closer, Dan. Okay, I'm stopping it.
At Endeavour's helm, Brandenstein delicately maneuvers the orbiter up to the 4.5-ton Intelsat 6.
The satellite is rolling out of control in 3 different axes at once, and you could actually fly the shuttle and fly this maneuver around and keep it aligned with it.
Right here. 3 people grabbed 18,000 pounds.
Aware that any miscue could endanger not only the satellite but also the ride home, spacewalkers Pierre Thuot, Tom Akers, and Rick Heed reach out and secure the satellite by hand.
Okay, wait. Let's do it. Got it. All guys are good? Yes, sir. Listen, I think we got a satellite.
Yeah, nice job, guys.
Intelsat 6 is released from the cargo bay with a new mini-rocket motor for a gentle push to its proper orbit, where it remains today, fully functional.